Hello physics students, so let's look at adding some vectors here. So both of these vectors have two components to them, a x component and a y component. So it's important for us to differentiate between those two components as we add the vectors together. And they only give us the value of the resultant vector here, so we're going to have to do some trigonometry to find the values of the x and the y components. Then we'll sum the x and the y components independently of one another, and then we'll find the resultant vector that results from combining those x and y components. So let's talk about how we would find this. So I'm going to call this one R1x, and this would be found using trigonometry. So this is compared to the angle. This side is adjacent. That's the hypotenuse. So you would use the cosine function. So it would be like cosine of theta equals adjacent divided by R1. Or if you move that around, then the R1 goes over on the cosine theta side, and it's equal to the adjacent side, and that would be basically saying R1, which is in this case 13.2 times cosine of theta, and theta 1 is 35 degrees. Okay, not a whole lot of imagination here to see that this would be the same thing except with sine. So I'm going to call this R1y, and I'm going to make it equal to 13.2 sine of 35. Alright, I'll change colors a little bit here, and we'll do the same thing with R2. Now, something important for you to notice here is that this downward pointing vector is going to be negative. If a vector points up or to the right, it's positive, as is customary with a coordinate system. And if it points down or to the left, then it'll be negative. All right, so similar process here. This one will be R2y, and then that's going to be whatever R2 is. So 3.1 times... Now check this out, be careful here. So the angle's up here in the top, so this is actually going to be a cosine function here, adjacent over hypotenuse. So it'll end up being 3.1 times cosine of 32. And this one, R2x, and by the way, whatever that comes out to be, make sure you do a negative of that. So R2x is going to be 3.1 sine of 32. Alright, so make sure your calculator's in degree mode, and I'm going to punch those numbers in and come back to you in just a second. Alright, so I spared you the pain of watching me do all the math there, and here's what all these come out to be. Now what we got to do is we got to sum the y, sum the x, and then we'll find the value of the resultant. So let's take a moment and do that. So basically, it's going to look like this. All right, and I'll pause and sum. All right, so here we go. Get my marker back here. All right, so x is going to be 12.45. And that's not a 7, by the way. Just a bracket. And then 4.94. Alright, so I guess if you're visualizing that, then our components here, we got one that's horizontal and one that's vertical. So this is the 12.45, and then this is the 4.94. Imagine those as the legs of a triangle. So our resultant vector is going to look like this, and then the angle of interest is going to be here. So to get the resultant, you can just use Pythagorean theorem. So a squared plus b squared equals c squared, so r squared equals 12.45 squared plus 4.4 squared. And then we'll solve for r squared. Alright, so I get 13.4 or 13.39. Probably will be accepted correct either way. Newtons. And then to get the angle, so we really could solve it any way we want to now because we have the resultant, but I'll use tangent because we have opposite of the angle and adjacent. So let's do that. So tan theta equals 4.94 over 12.45. Alright, so some people call that arctan, some people call that inverse tangent. On the TI calculators, I think they do like tan minus 1, and again, make sure you are in degree mode. So I'm just going to plug in inverse, or 10 to the minus 1, 4.94 divided by 12.45, and we can at least check here. So I get 21.6 when I do that. Ooh, need to change back to the marker. And that seems reasonable because, it doesn't go up as much as it goes over, so you'd at least expect it to be less than 45. Alright, so that's how you work those out and get the magnitude of the resultant vector and the angle, and that would be above the horizontal too, as that's stated. And if you have, from the positive x-axis, then the degrees are positive as you go around, or if it was below the x-axis, then it would be, negative degrees would work there too. Alright, so thanks for watching. Hope you found that helpful.